All right, these notes are on the characteristics of polynomial functions. Same definitions that we've worked with before. We're going to notice that for polynomials, they have their own kind of nuances that make them a little bit more simple in some situations, a little bit more difficult in others. So I'll go ahead and get started. We are not going to talk about transformations of polynomial functions because with polynomials we don't really have a parent function. Polynomials include quadratics, they include cubics, they include quartics, which is x to the fourth. They include a lot of things. It's kind of a generalization, and so we do not talk about transformations for this particular type of function. So here with the first example, even though it says example 4, we're going to talk about the domain and the range. So domain for polynomials is always easy. Your inputs are always going to be all real numbers. And you can tell from looking at the graph, these graphs always go forever to the left and forever to the right. They've got some curves in between, but there's no stopping. And if you think about the different pieces of the graph, there's no limitation to what you can do as far as raising a number to the fourth power, raising a number to the second power, plugging a number in for x here. So for the domain, for a polynomial, it is always negative infinity to positive infinity. So if you want to make a note on your calculator, if you want to make a note on your paper about that, you can. I said calculator because I'd already picked mine up. All right, for the range, some of these are easy. Some of them are negative infinity to positive infinity because you can see that the graph goes up and down, kind of like the next example. The graph goes down, the graph goes up. So if we were finding the range of this one, it would be negative infinity to positive infinity. But some of them, the range is a little bit more complicated, and which is why I chose this example. So for a question like this, we're going to have to graph it. So I've got negative x to the fourth plus 2x squared plus 2x minus 2. You can set your window here if you want to change it and make it 8 like it is on the paper so that it looks a little bit more like the paper, you can, but it really won't make much of a difference. So here's the same graph. I can see that the graph goes down forever. So I know that the range is going to start off as negative infinity, but I can tell it does not go up forever. It stops. It stops right here. And that point right there is called a maximum of the graph. It looks like a little mountaintop there. So what I'm going to do is I'm going to find the maximum of the graph. I'm going to do second trace. I'm going to look for that maximum, and that maximum is somewhere between an x value of 0 and 2. So I'm going to look for left bound of 0, right bound of 2, and that maximum, and these are typically always going to be funky decimal numbers. Not a lot of real nice answers here. So I'm going to go ahead and write down both coordinates because these are my notes and I want them to make a lot of sense. 1.191, comma, 1.207. And then we know with the range, we're talking about from down to up. And so when we do the range, we're going to be using the y coordinate. So the range is from negative infinity up to 1.207. That's an actual number that's on the graph. I can put my finger on it, and so that gets a bracket. So there's the domain, there's the range for that particular problem. Domain and range. All right. Increasing and decreasing intervals are a little bit more interesting for polynomial functions. They are not quite as interesting as they were for piecewise functions, but they're a little bit more interesting than most of the parent graphs that we've looked at so far, just because they switch directions so many times. So again, we're going to have to figure out what this high point is here. We're going to have to figure out what this low point is here. Those are the maximums and minimums. And so for us, the maximums and minimums with polynomials are going to be the thing on the graph that we find over and over and over again, which means I probably should have put it first in the notes, but I kept the notes consistent. I did the same order that we've been doing the whole time. So if you have a calculator at home, I would like for you to follow along and try to get these maximum and minimum points as well. because I want to make sure that you know how to find the maximum and minimum, and that way in class I can help people who don't have a calculator at home. All right, so I've got that. I went ahead and I'm graphing it, and it looks the same as what I have here. So when I do this, I don't need the entire maximum or the entire minimum. If you guys recall, increasing and decreasing intervals are only based on the x values. So I only need the x value of the maximum, I only need the x value of the minimum. And I can tell from this that it looks like it's at -4, but if I was doing it on this graph, it would be kind of hard to tell. So if you can't really tell where the numbers are in between. So before I could kind of tell it was between 0 and 2. It was pretty obvious. Here, maybe it's harder for you to count when there's a little bit more going on. So I'm going to show you a different method for how to find the maximum and minimum. We're going to find this one first. So we're going to find that mountaintop. I'm going to do second trace, option number 4. And instead of actually plugging in the numbers that we want to find, in between, we can hit the left and the right arrows and we can scroll. So I'm going to scroll, and what I want to do first is I want to have the cursor on the left side of the mountaintop. So I'm going to move to the left side of the mountaintop and press enter, and it doesn't have to be, in fact, I don't want it to be near the mountaintop. I want it to be definitely on the left side. So scroll to the left side, yep, that's on the left. I pressed enter, now it's asking me for the right side, so I'm going to scroll over to the right side by hitting the right arrow. Is that on the right side? Yep. Press enter. The guess is always silly, so I'm going to press enter one more time. So that x value is -3.99999. Pretty good assumption that that calculator is trying to say -4. So I'm going to go ahead and write -4 there. For the minimum value, I'm going to do second trace, number 3. I'll do the same thing. So I'm going to hit my right arrow. Now I'm on the left side of the valley, so I'm going to press enter. And now I'm going to scroll, so I'm on the right side of the valley and press enter. I'm going to ignore the guess and press enter one more time. And -1.33333. So I am only using x values. Now that's in your notes. It's only x values, it's only x values, but if you need to circle that or highlight it or something to remind yourself that increasing and decreasing is only x values, that could be good to do. All right, so I've got a right arrow that's a positive infinity. I have a left arrow that's a negative infinity. And right here, I've got a stick figure. And my stick figure is walking uphill. He is increasing up until he gets to -4. Then he turns around and he starts walking downhill. He's decreasing. Decreases down into that valley, hits -1.3333, and then starts increasing again. So since I wrote the word increasing twice, that means I have 2 parts to my answer for increasing. So increasing is written in between negative infinity and -4, so that's my first portion of the answer. Negative infinity, -4. And then increasing is written in between -1.333 and infinity, so I'm going to write that as my other portion. And then since I have 2 answers that both have to be there for me to get the answer correct, I have to put a U in between. And then decreasing, I wrote in between -4 and -1.333, and so I'll write this down, -4, -1.333. There is my decreasing interval. All right. Maximums and minimums, we've already been finding them, but the interesting thing about polynomials is it's not, and here we haven't been talking about absolute maximums, absolute minimums, where it is the very highest point on the graph, the very lowest point on the graph. We've just been talking about anything that looks like a mountaintop, anything that looks like a valley. So here we have a minimum here, but we also have one down here. And then we have a maximum right here. So there's actually 3 answers for this problem. 2 minimums, 1 maximum. So let's go ahead and I'll find one of them. Let's go ahead and find this minimum, and then we'll save the other 2 for finding in class. I want to make sure that we have a couple that we can look up together in class so that if people had a hard time doing it, I can help them. You guys will have to remind me we didn't finish this problem. So one of the minimums is this one down here. And I'm going to do second trace, option number 3. And I'm just going to scroll over. There's the left bound, press enter. There's my right bound, press enter. I'm ignoring the guess. I'm just going to press enter one more time. 1.838 for the x coordinate. And negative 3.309 followed by a 6 would be 310. All right. So I'm going to go back on the other side of my notes. I'm just going to write here, the maximum was second trace number 4. And the minimum is second trace number 3. All right. Next, we have x-intercepts and y-intercepts. So again, we can have more of these than we're used to seeing with a lot of these functions. So we have another polynomial function here, and if you look, we actually have 3 x-intercepts. And we have a y-intercept. You're only ever going to have one y-intercept if it's a polynomial function, because you can only have one spot with an x-coordinate of 0. But you can have multiple x-intercepts. So we've got x to the third minus 4x squared plus 4. And at this point, we should be really used to finding these on the calculator. So just a reminder, for the x-intercept, we're doing second trace number 2 because they're called zeros of the function. So the first one is between -2 and 0 somewhere, and even if you were looking here, you could see it's between -2 and 0. So if I can avoid scrolling, that's what I like to do, because scrolling back and forth, I think, is a time waste. But with the maxes and mins, sometimes you have to. So -0.903, 0. We're going to have lots of problems with decimals today, and so, or tomorrow when you guys work on this in class. And when we have decimal answers, I want to see 3 decimal places. And that's pretty much across the board. Unless I say otherwise, I want 3. The next one, I'll just look between maybe 0 and 2 or 0 and 3. So second trace number 2, I'm looking between 0 and 3. .1940, and then the next one I'll do between 3 and 5, somewhere in there. Left bound is 3, right bound is 5. 3.709. Now, I didn't even notice if it did this on the other ones, but if you see, it says 2e to the -12, and I've had students who weren't paying attention, and they wrote down that their x-intercept was 3.709, 2. This, you can write this down if you want. You cannot write this down, a little note to yourself. And yours might have done what mine did, but it probably doesn't have the exact same number here. Mine says 2e to the 2e -12, which is actually scientific notation on these calculators. It means 2 times 10 to the -12. And if you guys remember how scientific notation works, this is actually 2.0, and then you would take the decimal point and you would move it 12 places to the left. So keep moving, 12 places to the left. And so you'd have decimal point and then 0, 0, 0, 0, 0, all the way up to 2. So your calculator is saying 0, but it's kind of struggling to say 0. It's like that other problem where we had -3.99999, and we knew it was trying to say -4, but it was having a hard time. This is what it looks like when your calculator is struggling to say 0. So just a heads up, it's gonna happen on these assignments. It happens the polynomial day where we find the x-intercepts is where you're going to see it the most. Okay, so it can happen anytime, but this assignment in particular is where we see it. All right, y-intercept is second trace number 1. And that is not specific to the y-intercept. That allows you to plug in any x value, but the x value that we want to plug in is 0. So we're going to do second trace number 1, and we're going to plug in 0. So 0, 4 is the y-intercept. All right. Continuity, the graph is continuous. If you can trace it with your finger, that's not new. So this is not like the piecewise functions where we were picking up our fingers. We know that polynomial functions, just from sketching them so far earlier in the unit, we know that these are already going to be smooth curves. They are continuous. And I wrote that note here that polynomials are always continuous. So let's move on to end behavior. I only wrote one example down here, but we know from sketching them ourselves that the arrows can go all sorts of different ways. So at this point, hopefully end behavior is getting a little bit boring for you. But these don't have any of the fun or exciting answers. These are kind of the boring ones. So here I had a polynomial that had an even degree with a negative coefficient, so both arrows are going down. So I'm saying as you look at the left arrow, as x goes to negative infinity, it's pointing down, so y goes to negative infinity. As x goes to positive infinity, as we look at the right arrow, it's pointing down, so y also is going to negative infinity again. So both of these are pointing down. All right, so the only thing we have left to do not do this on your own, the only thing we have left to do tomorrow is to make sure that we are comfortable finding the maximums and minimums on our calculators.